Okay, so I don't want you to get the feeling that the only good use of an interface is for user input. There are lots and lots and lots of other interfaces. There are two that I use commonly, and one of them is Runnable and the other one is Comparable. They're used for very, very different things. Now, Runnable is the one that I want to demonstrate first. And it is used whenever you want to create a separate thread of execution. And so when do you want to do that? Typically, one occasion is whenever you want in your program to handle some external component of your computer, like the monitor. So for an animation, so if you have an animation, you want to create a separate thread of execution that is constantly updating the screen or updating all of the objects that are displayed on the screen. Another external thing that you would like to maybe control is a microphone and speaker. But there are other occasions, so say for example if you want to control a printer, you want to send something to the printer, you want to start up a separate thread of execution that sends that print off to the printer, but you don't want your program to stop while that thread is running and to just hang there while the print is going off. Anytime you have some sort of external device and your computer has to talk to that external device and you want it to do so independently without making the rest of the things in your program hang up, you're going to need to implement the Runnable interface and create a separate thread of execution, or use somebody else's library where they've done it. So in this demonstration, I'm just going to create a dot that bounces off the corners of the screen because it's an easy animation to do. Okay, so what I've got is basically just kind of our standard class that extends JFrame. It's got a main method that creates an instance of the class, sets the size to some width and height. I've declared a couple of variables that are final for the width and height. I've set the default close operation, set resizable to false, and set visible to true. You've seen all that before. I've created two new variables, X and Y, because I want a dot that moves across the screen. It's going to have some XY location on the screen. And I've created a constructor that just sets those to roughly the middle of the screen. And then because I want to draw a dot at those locations, I need a paint method. And in my paint method, I'm just going to clear the screen to black. So I set the color to black and I fill a rectangle from the upper left-hand corner, 0, 0, the full width and height of the screen. Then I set the color to red and I fill an oval at X and Y with a width and a height of 20, which, you know, if they're the same, it's just going to be a little blue red circle at the center of the screen. So if I run this, it tells me I've got errors because my comparable thing. I wonder if I can get away with that. Yeah, okay, that works. I'll fix that up later. So that's my black screen with a red dot. Nothing too fancy. Now I want to make this thing run. I want to make it move. So I need a separate thread that is constantly updating the position of this dot. So I'm going to say implements Runnable. And I have to add the unimplemented methods. And in run, I'm going to change the position of my dot. So I've added a run method. So I've implemented Runnable, I've added a run method. Inside of that run method, I've created a loop that says while true. That just means forever. Okay, that's a forever loop. Increase X and increase Y and then repaint. But if I run this thing, it doesn't do anything. Because just like the other interfaces, just implementing the interface isn't enough by itself. I have to start this thread running. And how do I do that? Well, in the constructor I can say new thread, and when I create that separate thread of execution, I have to give it something that implements Runnable. And since this JFrame implements Runnable, I can just say this, and then I'm going to tell that thread to start. And so now when I run it, the dot should, I hope, move. Okay, the dot is gone. What happened? Well, this is a really, really, really fast loop. It doesn't take hardly any time at all for that dot to be off the screen, and so by the time my dot is visible, it's already gone off the screen. So I have to slow it down a little bit. I'm going to say thread dot sleep 30. That tells this thread to fall asleep. It'll fall asleep for 30 milliseconds and then wake up. And so it's going to make it through this loop about 30 times a second, which is a lot slower than it was going before. You notice that it's all underlined in red though. And that's because the sleep function doesn't always succeed. And sometimes something's going to get interrupted while it's trying to sleep. And if that happens, you have to catch that exception. And so Eclipse tells you that it's an error. It suggests to surround it with try catches. We do that. That gets rid of the error message, and now we can see our dot move. But I want it to bounce off the sides, and it's not. It's just going and going and going. Alright, we can make it bounce. Okay, so just to make it a little more interesting, I made it bounce off the walls. So in order to do that, I had to give it not just a position, x, y, but also a velocity. So I set the velocity to some positive values, didn't really matter what, that just gets the dot moving. And then inside of the run method, instead of just adding 1, I add the velocity in the x and the velocity in the y. And then if x is greater than this width, meaning if it's gone off the right hand side, or x is less than 0, meaning it's gone off the left hand side, change the velocity. Just multiply it by -1. So if it was positive, it becomes negative. If it was negative, it becomes positive. So if that'll bounce off the left and right walls. And y is the same thing, except that it's greater than the height instead of greater than the width. So that'll bounce it off the top and bottom. If I run it, okay, so it bounces off the sides, and if we waited long enough, it would bounce off to the left. I'm not going to wait that long. So the idea for the runnable interface, the things that you need to know, what are the steps? You have to have something that implements the runnable interface. You have to implement the run method. And then you have to create a thread and tell that thread to start. As soon as that thread starts, you'll have a separate thread of execution that goes through, that executes that run method. Now, in my case, I've got an infinite loop. And I'll often do that. It's just something that is constantly running in the background. But it's not always the case. Sometimes you want something that will eventually terminate and finish on its own. So the last thing is the comparable interface. And so I've created a separate class that implements the comparable interface. This is a little bit different because this is a typed interface. So we get this warning. And neither one of the quick fixes are what we want. So a typed interface, for a comparable, we want this thing to compare to another thing of its own type. So I'm going to say my comparable thing. Okay, so typed classes are a little bit confusing. Inside the angle brackets, you put the type. Okay, we've seen that a little bit with array lists. So if we implement the comparable interface, we got to tell it what kind of thing we're comparing it to. And generally, if it's a class, we're comparing it to another instance of itself. If we're going to be using it with the collections class, that's what we have to do. So then we implement, or we add the unimplemented methods, and the method that we have to implement is compare to. Now this method has to return a positive number, a negative number, or 0. So the way the compare to method works is it's got to return a positive number if the one object is bigger. And so if the object that's executing this method is bigger, it returns than the object received by the method. It returns a 0 if the object executing the method is equal to the object that is passed into the method. And it returns a -1 if the object executing the method is less than the object that was passed in. So I gave each of the comparable things some value, okay, and it's going to be a double, and I'm just calling it my random value. And in the constructor, I set the random value to some, well, random number using math.random. In the compare to method, I'm just going to say if this dot my random value is greater than O for the other thing dot my random value, then return a +1. Okay? So if I'm bigger than the other guy, I return a positive number. If this dot my random value is less than the other object's random value, return a negative number. I'll just say -1. Otherwise, they must be equal, so return 0. Now, back in my demo, the class with the main method, okay, or the demo, right before I say set visible to true, I'm just going to go ahead and create an array list of my comparable thing. Call it sum list. Okay, so that sum list equals some new array list of my comparable thing, and then I'm going to put 10 items in it. So for I equals 0, I less than 10, I plus plus sum list dot add, and I'm just going to create a new comparable thing. And each one of those 10 things is going to have its own random value. And what I'd like to do is I'd like to print this thing out, sort it, and then print it again so that you can see that it was actually sorted. So if I want to print it, I can try and just print out list. But that is not going to look real pretty. It printed out all of my comparable things here in a list, but it didn't look very pretty. What's it printing and why? Well, every object, remember that whenever you create a class that extends object, it inherits certain methods. One of those methods is the toString method. So if we scroll down here, we've got a toString method. Okay? And that method converts the object to a string, and if you just print the object, the string that you inherit, that you get from that inherited method, is the string that it prints. And the inherited method prints out the type of the object and the address where it's stored in memory. But that's not pretty, and it's not a whole lot of information for us. What I would much rather have is I would much rather have it print out the random value. So I'm going to override the toString method. I'm going to say public toString return double quotes for an empty string plus my random value. And what that does is whenever you add something to a string, it converts this thing to a string, and then it's going to concatenate the two. So an empty string with this is just this double value converted into a string. So now the toString method instead of returning the type of the object and the address in memory, it's going to return a string which is equal to the random value. So now if I run this thing, where's my error? What did I do? Whoops. I get a bunch of random values all in random order. Now, here's the trick for sorting. I can say collections dot sort and I'm going to sort some list. Now here's the trick. The collections class has a static method called sort, and the thing that you pass in has got to be something that implements the list interface. Well, ArrayList implements the list interface. But not only does it have to implement the list interface, it has to be a list of things that implement the comparable interface. And so my comparable thing implements the comparable interface. It's got a valid compare_to method. And the ArrayList has all the valid methods that the collection class needs to be able to sort. So it's going to sort all the stuff in that ArrayList. And now if we say system.out.println SUMList, my comparable things are all in order. And if we scroll along here, this 244643, that thing is going to be in there somewhere. There it is. Every item that was in it was printed the first time is still in it, but now they're in increasing order. And so if you have some class, some object that you've created, you put it in a container and you want to sort it by some value, all you have to do is implement comparable, and then you can just say collections.sort, and all your stuff comes out sorted. Isn't that cool?